All right, so we are on comparing. This time we're comparing slope and the y-intercept. So we will be given a scenario for two different people comparing something similar, except the way that the information is presented will be in two different models. So for this one, there's a lot of examples here. If you need the extra practice, you can do all 7 examples. Otherwise, I want you to complete the 2 in this video and then choose 2 to do on your own without my assistance or the assistance of the answer key. So for this first one, for all of them, I should say, we're going to determine, then compare the rate of change, which is the slope for each function in the context of the problem, and then determine and compare the y-intercept for each function in the context of the problem. So number 1, on the track team, 2 long jumpers, Oscar and Monica, are steadily improving their maximum distance during the course of the season. Their distances jumped as a function of months are shown below. So Oscar's data is shown in a chart and Monica's distance is shown in a graph. So we have, for both of them, we have months as the x value, the independent, and our dependent variable, which is our y's, our distance in inches. Okay? So where should we start? Let's start with y-intercept because I think that one is easier for most students. So let's start with the easy one first. Okay, so y-intercept is going to be our initial distance. Or when x equals 0. So looking at just Oscar, remember, months is an x value, inches is a y value. So right here, x equals 0. So this is my x-intercept. And I'll write it as a coordinate, x comma y. So we have, for Oscar, we have 0, 235. So initially, Oscar can jump 235 inches. And then let's do the same thing for Monica. So y-intercept for Monica, it's when x equals 0 or when our line crosses the y-axis. Oops, that's got a little crowded. Axis. Okay. Okay, so when x equals 0 right here. So we're looking at like this line right here. Our point right here. They gave it to us as a coordinate 0, 200. So for Monica, our y-intercept 0, 200, meaning that initially Monica jumps 200 inches. And then for our slope, remember we have rise over run. So we have y values over x values because rise is going up and down. Those are y values, up and down axis, over our x values. It's on the x-axis, left to right, so run. Y values represents inches per x value is months. So inches per month. So I need to find the difference between the y's, difference between the x's. So difference between the x's, from 0 to 1, I add 1, 2 to 3, add 1, 3 to 4, add 1, and add 1. And then for my y values, from 235 to 236, we add 1, add 1, add 1, add 1, add 1. Okay, hopefully that wasn't too hard to see that we're just adding 1 to get to the next term. So y's over x's, difference in the inches over difference in the distances. Difference in the inches with the distance over difference in the months. Ooh, that's a tongue twister. Okay, so that'll be for Oscar. It'll be 1 over 1. So his slope is going to be just 1. Each month that goes by, he improves his distance by 1 inch. Okay, and then for Monica, we'll use, we're given these 2 points, so we'll use the slope formula, which is difference of the y over distance of the x. Okay, so y1 minus y2 over x1 minus x2. y1 will be 200 minus y2, which is 206, over 0 minus 6. You could also have it as 260 or 206 minus 200 over 6 minus 0. Both of them will give you the same answer, so don't worry. 200 minus 206 will give me 6, negative 6. 0 minus 6 will give me negative 6, and that reduces to 1 over 1, which is 1. So for Monica, explaining that in the context, Monica improves her distance by 1 inch each month. Okay, so we have our y-intercepts for both individuals and the slopes for both Monica and Oscar. We notice that their slopes are the same, so they have the same improvement each month. They're both increasing their distance by 1 inch each month. However, initially, Oscar had a further distance, so he started jumping farther than Monica. And then let's try number 2. Tremaine and Jose leave Los Angeles at different times and drive up to Interstate 5 towards San Francisco. These functions show their distance from LA over the course of time. So Tremaine's speed is given as an equation, and Jose's speed is given in a graph. So again, we'll find y-intercept and slope for each of them, and then we'll explain in the context. So for Tremaine, let's do the y-intercept. Remember, we have y equals mx plus b. B is our y-intercept. Since there's nothing under the b for the b value, we can assume it's a plus 0 because plus 0 doesn't change anything. Just like if I want 2 plus 0, it's still 2. Okay, so Tremaine's y-intercept is 0, 0, meaning that his initial speed was 0, or let's see. So 0, 0 is my y-intercept. So that means that Tremaine started at 0 miles initially. Once we look at Jose, we can explain this a little bit better in context. So let's look at Jose. Where we cross the y-axis is our y-intercept. So right here, this is Jose's y-intercept. So it means that at hour 0, he was 100 miles away from San Francisco. So that means that Jose and Tremaine are 100 miles apart. They started 100 miles apart in their drive up Interstate 5. And now let's look at their slope, which equates to their speed. And for slope, for Tremaine, it is our M value, which is 60. So in context, Tremaine travels 60 miles per hour. And then if we looked at Jose, let's use, let's see, do we have any nice points? No, not really, just the 2 points given. So let's use the formula y1 minus y2 over x1 minus x2. So we have 100 minus 175 over 0 minus 5. So that gives me negative 75 over negative 5, which, oh, wait. No, I made a mistake. Negative 100. There we go. Negative 100 minus 175. Ooh. Okay, so negative 275 divided by 5. It gives me positive 55 over 1. So in context, Jose travels 55 miles per hour. Yeah, and that completes that one. Number 3 is going to be something similar to question number 1. Question 4 is going to be similar to question number 2. Number 5 is something new. Number 6 is something new. And number 7 is going to be something new as well. So I want you to, gosh, there's even more. Okay, you've got 8 to choose from, 9 to choose from, 10 or 11 or 12. So I want you to attempt 2 of these on your own.